Let's take a look at this problem. We are given the cation zinc 2+ and the anion ClO4 -1. Just like we've done previously, let's go ahead and write the cation into the left side of the table and the anion in the right side of the table to determine how many of each we need in order to make a neutral compound. So zinc's oxidation number is +2 and perchlorate is -1. Well, how many zincs will we need and how many perchlorates will we need? We need another perchlorate so that our oxidation number is a total of -2 for the anions. +2 minus 2 is equal to 0. So how many zinc ions did we need? We only needed 1. How many perchlorate ions did we need? We needed 2. Is the overall charge of our compound equal to 0? Yes, it is. +2 minus 2 is equal to 0. We have a neutral compound. So what is the chemical formula for this compound? Well, we needed 1 zinc and 2 perchlorates. Now I'm going to write that inside the parentheses because remember, these are polyatomic ions. Polyatomic ions meaning multiple atoms or many atoms in one. So we need the parentheses because we needed 2 perchlorate ions. If we only needed 1, then we would not use the parentheses. Keep in mind that you do need to write the 4 inside the parentheses and then the 2 goes outside of the parentheses. So let's take a look at this practice problem where we are given the name and we need to determine the formula. You'll notice that the 3 steps are the same as before. So we need to determine the symbols and the oxidation number of both the cation and the anion. And you'll notice that in the name, it's still placed in the same way where it's positive, so cation first and the anion second. So the cation is ammonium and the anion is Cl -1. Step 2, how many of each do I need to equal 0? So let's go ahead and write our cation and anion again. We have a charge of +1 and -1, and that's all we need. When you add those up, it will equal 0. So now let's write the formula. Cation first, NH4, and then the anion Cl. So in this case, ammonium did not need parentheses because we only needed 1 ammonium. So pause the video here to work on these practice problems. Given the name, write the formula. As before, you may use the middle columns or you may eliminate the columns as you get comfortable. Refer to your list of polyatomic ions to help you complete these problems. Now let's look at an example where we are given the formula and we need to write the name. Again, you'll notice that the 3 steps are similar to the last time we talked about ionic compounds. So we're going to write the name of the cation and the anion. So Cr is chromium and SO4 is sulfate. Step 2, is the cation a mom? Remember what mom stands for, multiple oxidation metal. Chromium is a mom, so we need to calculate the oxidation number. If you look at the formula, how many chromiums are there? There's 1 chromium ion, so we write Cr with a question mark because we're trying to determine the oxidation number. And then how many sulfates do we have from the formula? We have 2, so we write sulfate twice. And the charge for sulfate is 2-. So the total charge of our anions is -4. That means the cations have to be +4. And there's only 1 cation, there's only 1 chromium. So that chromium must be +4. So now let's write the name. Chromium 4IV sulfate. The name is chromium 4-sulfate. Pause the video again to complete these practice problems. Given the formula, write the name, and again refer to your list of polyatomic ions to help you complete these problems.